All right. So right now, so sulfur is the next one that I wanted to go over. I had some technical issues yesterday. Some save files got like messed up and everything. So I'm just gonna limit the amount of videos I'm gonna do for this project because time is of the essence right now. I mean, there wasn't much to miss. There was some stuff about oxygen, but I mean, I already went over most of the stuff that I wanted to go over anyways. The only one that was kind of significant was copper with its electrochemistry stuff, but it's kind of simple. It's just a bunch of reduction stuff, blah blah blah. But anyway, so today we're gonna be going over sulfur, and sulfur has many different allotropes. An example of an allotrope is an allotrope is where it has two or more different physical forms in which an element can exist. So an example would be like rhombic sulfur, monoclinic sulfur, plastic sulfur, or even as we mentioned in the carbon video, graphite and diamond. Those two are also allotropes. But anyways, like I said earlier, it's possible to violate the octet rule, and sulfur is the first element that we're going over today that we're going over in this series that can actually violate the octet rule for those structures. So as you can see here, we have SF6, sulfur hexafluoride, and as you can see, it has 12 electrons surrounding it. And the reason why I can do that is because it can stuff all the electrons into a d orbital, and anyways, but since sulfur is also involved in a ton of like solubility rules and stuff, I thought I might as well mention the solubility rules here for the first video. So group 1A cations like Li plus, Na plus, K plus, Rp plus, Cs plus, and ammonium, they're always soluble when it's in an ionic compound. There's no exceptions to this rule. And yes, I know the quality is probably kind of blurry for this image, but it's the most consistent one with the type of rules, with the solubility rules that you'll need in um, like Gen Chem 1, AP Chem, and just overall. Nitrates, perchlorates, acetates, chlorates are all soluble with no exceptions. Chlorides, bromides, and iodides are all soluble except for when they're bonded with silver, mercury, or lead. Sulfates are all soluble unless it's bonded with strontium, barium, mercury, or lead. S2 sulfides are insoluble unless they're bonded with the group 1A cations, NH4 plus, Ca2 plus, Sr2 plus, and barium 2 plus. Carbonates are insoluble unless it's bonded with group 1A cations and NH4 plus. Hydroxides, same thing, but they're also like strong bases are all soluble too. So calcium, strontium, and barium hydroxides are also all soluble. And phosphates is just the only exceptions for phosphates being like Alright, so the only time phosphates are actually soluble is when it's bonded with one of the cations from group 1. And that's about it for the sulfur category. I know I mixed in a ton of stuff into this video, but that's about it for the project too. I might upload more on this channel later on. Maybe some sports stuff, maybe some other stuff, but that's about it for the chemistry stuff. I mean, obviously, I'll probably still upload some stuff for the chemistry, maybe. I don't know. It depends. We'll see. But yeah, thanks.